Today in the workshop, we'll be working with the PlutoX Aerial Robotics Kit, a DIY drone that you can program and add your own hardware to. We'll learn how PlutoX works and how to program with the Cygnus IDE. Get ready for takeoff, and welcome to the workshop. Hello and welcome to the workshop. Today in the DroneBot workshop, we are finally going to get around to working with a drone. I know a lot of you have been wondering, why is it the DroneBot workshop? He never talks about drones. Well, today that changes, and I am going to be working with one. Now, this is a very special drone. Unlike a lot of commercial drones that you just take out of the box and you fly, this is an experimenter's type drone. This is a drone that you can add hardware to, so you can do your own experiments. This is a drone that you can reprogram. In many ways, you can treat the drone itself like a Raspberry Pi or an Arduino, as a programmable device that you can create your own things with. So, with apologies to all you Star Wars fans, these are the drones you're looking for. Not pretty bad. But this is the PlutoX. The PlutoX is made by Drone Aviation in Mumbai, and they were kind enough to send me out one of these drones, and when they told me about this, I was absolutely thrilled. And I can show you actually what I think is one of the greatest features of the PlutoX. This is something that they call a Basic X expansion card, and you can use this to add hardware onto it. There is a connector on the top of the PlutoX that this card will plug into, and here's another one I've got that actually has got some components soldered up to it already. Now, the PlutoX has a GPIO connection. It has things like the I2C and SPI bus, plus it also has digital and analog connections. It has drivers for motors. This doesn't even need to be a drone. You can reconfigure this to be a rover. You can add wheels to this and make it a hybrid device, so both a drone and a rover. There virtually are endless possibilities you can work with. Now, I've got some of the parts for the PlutoX over here on the workbench. I've got the drone itself. Here are a couple of the Basic X expansion cards. This is a blank one, and this is one that I've got a few components soldered onto. This is a little camera. Now, you can use the camera for FPV purposes like you can with any drone, but the real fun with this camera is to use it for things like object tracking and make it part of your programming for the drone. These are a couple of extra motors that you can attach to it and a few wheels, because as I said, this can also be a hybrid device. So today what I'm going to do is I'm going to show you the individual components in the PlutoX. Then we'll look at how to get the drone set up, and we'll also look at the Cygnus IDE, which is the programming environment we use to program the drone. So there is quite a lot to cover today, so let's get started. So here's what I received in my PlutoX kit. Now bear in mind I got an advanced kit, so what you get in your kit may slightly differ, but I'm sure it's going to be just about the same stuff. Now, in the center, obviously, we have the PlutoX drone itself. The drone is made on a 3D printed frame and is apparently been tested to a drop of about 6 floors, so it's quite durable. There's a place underneath here to slip the battery, and they provide a 600 milliamp hour battery for you, which is very nice for a nice long flight time. It's got prop guards and propellers. These are not 3D printed, and they give you a couple of extra propellers, which is really nice, especially since on my maiden flight I managed to break one, so thank you very much for giving me the extras. There's what I would call, for a lack of a better word, just some PlutoX swag, a little rookie pilot badge, and a couple of stickers and that you can dress it up with. By the way, the final unit, I believe, also has a cover for it. I don't have the cover myself, but I think you can even get it in a couple of different colors, so place for you to stick your PlutoX stickers. Now, these are a couple of little motors that come with it, and these little brackets on it are made to snap onto the bottom of the drone. I don't know if you can see that, but they've got some little snaps over here that you can place these brackets onto. And these motors and the accompanying wheels are meant if you're going to use this as a hybrid drone, so that you can put a few wheels on the bottom of this, have a device that flies and then gets down to the ground and drives around, which is pretty amazing when you think about it. A couple of extra motors, which is very nice. Two of the basic X expansion cards. Now this is a blank card over here that you can just use to wire your own sensors and devices onto it. Apparently the payload capacity of this is about 15 grams, so as long as you don't exceed that, you can put all kinds of sensors and indicators and experiments onto this. This one has already been wired up for me, and I'm looking forward to testing this one. It has two time of flight sensors, and these are actually laser based. Believe it or not, there's a tiny laser in here and a sensor, and these devices are sensitive from a range of about 50 millimeters to 1.2 meters or even more, and quite accurate. And they've got them on opposite sides over here, so obviously these will be very useful for an experiment. Now these Basic X cards have a GPIO connector on the bottom of them over here, and you'll see the equivalent connector on the PlutoX. And so if I can just do that for you, that just snaps onto here, and so you've got your expansion card on the top over here. And as I said, it can take a payload of about 15 grams, so you can wire other sensors, etc. up to it, whatever your heart desires. So this is the part that really intrigues me, the experimenter's aspect. Now, this is the camera that came with the PlutoX. It's a pretty standard camera build. It's got a slot for a micro SD card so that you can record video on it. This is just a connector. It's a power connector that runs up to the PlutoX itself, so you can power the camera. And once again, it's got little notches on it so that you can place the camera underneath the drone over here and snap it on. So we'll be working with the camera a little later on and show you how it works. And so that's basically what I received in the PlutoX box. Now what I want to do is take a closer look at the features of this drone itself. So let's go do that now. The PlutoX drone is billed as an aerial robotics kit. It's a do-it-yourself experimenter's quadcopter. The device has a payload capacity of up to 15 grams, allowing you to add your own devices and circuitry to it. It has an altitude hold mode and a headless mode. You can program the PlutoX using the Cygnus IDE. You can send your programs to the Pluto without a connection using its wireless flashing mode. The PlutoX drone has 4 H-bridge motor drivers. These are what are driving the 4 motors on the quadcopter. There are an additional 4 MOSFET drivers for additional motors and other high-powered devices. It has an onboard 10-degree of freedom sensor suite and includes an altimeter, a barometer, and a magnetometer. The device uses the ESP8266 for its Wi-Fi interface. External circuitry can be connected through a 20-pin unibus GPIO connector. The 20-pin unibus GPIO has several connections. Some of them do double duty. It has 8 analog inputs, 11 timer channels, 2 UARTs for serial communications, 2 digital to analog converters. The GPIO also has an I2C bus connection, an SPI bus connection. The GPIO can supply 3.3 volts DC to external cards at up to 500 milliamps. It is made to mate with the Basic X expansion cards. For more information about the PlutoX, you can visit flyplutox.com. So now that I've showed you a little bit about the PlutoX hardware and its capabilities, it's time to actually start working with it. What I'm going to do is I'm going to set up the controller first and show you how to do that, and then we're going to move on to the Cygnus IDE, the development environment that we use for writing code for the PlutoX. And we will start writing some actual code for it and see it in action. So there's a lot to cover. Let's get started. Now, the Pluto app is an app that's available for both Android or iOS. I'm going to be using an Android version on this Android tablet, but of course you could use an Android phone. And if you're using the iOS version, that means you could use either an iPad or an iPhone for it. And the interface, I believe, is pretty similar. Now, in order to work with the Pluto, I'm going to be connecting to it via Wi-Fi. So the first thing I'm going to do is turn the drone on. It's on right now. Then I'm going to go into my Wi-Fi. And I'm going to look for it. And here it is. Now, I've already set up the credentials on mine, but of course the first time you do it, like any Wi-Fi connection, you will need to set credentials up. So basically it's telling me I've connected, but I have no internet, which makes perfect sense because I'm connected to the Pluto and not to my actual Wi-Fi network. Now, I've already downloaded the app from the Google Play Store. I will give you the link in the article in the dronebotworkshop.com website so that you can download either the app from the Play Store for Android or from the Apple Store for the iOS app. We'll start the app, and it boots up like this. Now, before I connect to the drone, what I want to show you is that they actually have a little walkthrough thing here in the app that shows you what all the controls do. So it's kind of useful to use that. So let's go into the menu, and we go into the help, and do the walkthrough. And so it starts off by showing with the menu settings. The developer mode it just showed you is very interesting because we're going to be using developer mode when we actually program the Pluto. Anyway, it's giving you indications about the status and all that. Next, it'll show you what the control does over here. And this basically seems to control the yaw right now. And the pitch. So pitch and yaw are controlled by this control on the left side. If I go to next, this control pretty well does the roll and the tilt over here on this side, which is pretty standard for joysticks on a drone. Now, personally, I kind of like the feel of a joystick on an actual controller as opposed to an app, but this one does actually work good. You just have to get used to the sensitivity on it, etc. And that's basically the walkthrough right now. So we'll finish that. Now I'm going to connect to the Pluto right now. So I basically hit the connect button here.
Pluto connected.
And it tells me the Pluto's connected. Well, wonderful. Okay, now again in the menu, I'm going to go to drone settings. There's a whole world of things over here that you can do. For example, you can calibrate the accelerometer and the magnetometer by basically having it sit on a flat surface for the accelerometer and by moving it into a number of positions for the magnetometer. So I won't do that right now, but basically it'll walk you through that. Interesting over here, they have a motor test thing, so let's give that a try. Here's a motor. Got motor M2, and it shows you the motor spinning, and you can see the motor on the drone is spinning. Let's go to this motor. I can even spin them all. So basically I can test my motors. That's really great. What's neat over here are some of the sensor graphs they have. Now here's the accelerometer, so I'm just going to move the drone around a little bit. And you can see that I'm getting readings over here on the X and Y and Z axis. Gyroscope, a similar type of thing. Now the magnetometer and the barometer, I'm not going to really get readings on down over here simply because at the level I'm going. You can see a vague reading on the magnetometer, and the barometer, I wouldn't imagine the air pressure is going to change extremely. You can see a slight change, but it's not huge in the short distance that I'm able to lift it with my hand, but that makes perfect sense. Go back over here. And you can set up the Wi-Fi name and password, etc. through this as well too, if you wish. Okay, now obviously you'd like me to fly this right now. After all, it's a drone and we're going to fly it. I'm not going to fly it right this second here in the workshop, and the reason is the workshop's a very confined area and I'm not a particularly good pilot, so the chances of this drone flying into something in the workshop, like my oscilloscope or my monitor or one of the cameras that I'm using to film this right now, or into me, is pretty high. So we will, I promise, fly the drone before the video is over. I'm just going to take it to another area to do that. But I just wanted to show you the PlutoX controller and how versatile it is, and what you can do with it. Now, one thing to remember is that there was a developer mode. That's this little button over here. And when you're in developer mode, you can actually start writing software for the Pluto and load it up to the Pluto. And that is what we are going to be doing. But in order to do that, we're going to need another software product called Cygnus IDE. And so we're going to talk about that. So let's discuss how you program the PlutoX. The PlutoX is programmed using the Cygnus Integrated Development Environment. The Cygnus IDE is available for Windows, the Macintosh, and for Linux. The programming itself is done in C++, similar to the Arduino. There are APIs available to control all of the onboard hardware on the PlutoX. The PlutoX programming structure is quite similar to that of the Arduino. All PlutoX programs need to include the PlutoPilot library. Your program is compiled and then flashed over to the PlutoX. Now there are 4 common program functions in every PlutoX program. Let's take a look at them. The first function is Pluto init. This is the PlutoX startup function. It's called when the PlutoX hardware starts. This is where you would put hardware initialization code for any additional hardware that you are adding to your PlutoX. The next function is onPilotStart. This is the developer mode startup function, and it's called when the developer mode is activated. This is where you would initialize variables and run one-time code. In many ways, this is similar to the setup function in an Arduino. PlutoPilot is the developer mode main function. Code in PlutoPilot runs as an endless loop, so this makes it similar to the Arduino loop function. You'll place the main code for your program in here. And then finally, onPilotFinish. This function is a developer mode finish function, and it's called when the developer mode is deactivated. You would generally place cleanup code into this function. Now once you've finished and compiled your program, it's flashed to the PlutoX using Wi-Fi. All custom programs on the PlutoX execute in developer mode. You'll enter development mode using the PlutoX controller app. You will notice a button on the bottom left corner of the app. This is the developer mode button. So now let's program our PlutoX. So let's take a quick look at the Cygnus IDE interface. Now I've installed this on Microsoft Windows, but the interface is similar in Linux or on the Mac. So I'll start my IDE. And when it opens up, I can see the main sections of the IDE. On the left side, I have a Project Explorer. There's an outline on this side, which will be populated when I actually have a project. And at the bottom, I have properties, a console, an error problem area, and 2 monitor areas, which we will look at a little later. Now, in order to create a new program, I'll go into File, I'll do New, and PlutoX Project. I'll give my project a name. And in the center, we will see that my project is opened up. Now, like the Arduino, this will enter some blank areas for the common functions. So you will notice the 4 functions that we discussed when we discussed PlutoX programming. The Pluto init, onPilot start, Pluto pilot, and onPilot finish. You'll also notice that the Pluto pilot library has been included for us. Now you can see on the outline side, we will see all of the different functions that we've created and the library. Now that we've seen the interface, let's actually write some code for our PlutoX. Now, when you learn a new programming language, or when you're working with a new programming environment, it's pretty customary to start off by using a Hello World type of a program. Now, with the Arduino, the Hello World program would be the blink sketch. It's the first thing most of us learn when we learn to program in Arduino. Well, Drona Aviation, the people who have built the PlutoX, have provided sort of a Hello World program itself. It just shows you how you can program on the Cygnus IDE and how you can flash things over to the PlutoX. So I've got my computer over here, and on the other workbench I've got my PlutoX sitting there, and I'm going to turn it on after I program and flash my program from the computer to the PlutoX, and we'll take a look at how it works. So let's go ahead and do that. Now here's the program that Drona Aviation provided. They call it Debug APIs, but you can really name it anything you like when you save it. Now again, this is a very basic program. The function of this program is to control 2 of the LEDs that are on the PlutoX. Now these LEDs normally indicate flight status, but we're going to use them instead to indicate whether the Pluto is moving up or moving down. In other words, on the Z-axis. If it's moving up, we'll put one of the LEDs on. If it's moving down, we'll put the other one. And so when the project works, we should be able to pick the PlutoX up by hand, move it up and down, and observe the LEDs changing colors. So it's a very basic program, but again, it gives you a good introduction to PlutoX programming. Now, our program starts off by loading the Pluto pilot, like all Pluto programs do. In addition, we also load libraries for other functions, the LED, the control, altitude hold, and a print function, which is actually a function that prints out to the console on our Cygnus IDE. Now, there is nothing to do in Pluto init. There is no additional hardware being added to the Pluto, so we don't do anything down over here. On Pluto Start, we will disable the flight status, and that is because we want to use the 2 LEDs that indicate flight status for our own purposes. Now we go into the Pluto pilot, which is basically the loop section of the Pluto code. And so we take a look at the altitude by using the get velocity Z, or get velocity Z if you prefer. Now this gets the velocity on the Z axis, and we find out if the velocity is greater than 0, in other words if it is positive, and we turn one LED on and the other one off, else it is less than 0, which means the velocity is negative, the device is moving downward, and we do the opposite. We turn the other LED on and the other LED off. And then we do the print function. Now this is out to the monitor that is actually on our Cygnus IDE. So we're going to see the results down over here under Pluto Monitor. And we print to the monitor the actual velocity, and then we're going to print a graph. If we go into Pluto Graphs over here, we'll find there's actually 3 graphs, a red, green, and a blue graph. And we're going to print to the red graph, and we're basically just going to print the altitude. So we should be able to see on the graph the altitude moving moving up and down as we move the Pluto up and down. Finally, on the onPilot finish, this is the function that occurs when you take it out of developer mode. We turn disable flight status to false. In other words, we enable the flight status, so the PlutoX is left in its normal position, and so when it's used normally, it'll function just as it normally would. And so now that you've seen the code, the next thing we need to do is to build the code and to flash it over to our PlutoX. And so I'm going to show you how we do that right now. Now, before I build my program, I want to just set up the Wi-Fi connection to my PlutoX. So I've turned on the PlutoX, and as you can see, it's got a couple of lights flashing on it. Let's connect it to the Wi-Fi on this computer. So I'm just going to open up another desktop so it's a little cleaner. And you can see my Pluto over here, so I'm going to connect to it. Okay, and it's connected, and as it says, there's no internet, which we wouldn't expect. So let's go back to the desktop that has our Cygnus IDE on it. Alright, now in order to build the program, we are going to do a build, and build is just up over here. We hit this little icon here, and the build operation is in process. And my project has been built successfully. And the console displays a little bit of information about the build if you're interested in it. Okay, so now the project's been built, it is now ready to flash over to the Pluto. So down here we have a menu that has both normal flash and full flash. A normal flash will just flash the program to the Pluto, but it will keep all of the Pluto calibrations intact, whereas a full flash will wipe out the calibrations and set everything as if the Pluto was brand new. I'm going to use a full flash right now, and the thing about that is once you do that, you need to go into your Pluto controller and redo the calibrations. But a full flash is always best to do when you're first starting a program off, because then you're sure that the programming environment is set to the way you want it set. So I'm going to do a full flash. And you'll notice some of the status lights in the PlutoX have changed while I'm flashing to it. And if you saw that little burst of activity on the Pluto, it happened at the same time that I was told that the firmware is flashed successfully. So now we've flashed it over to the Pluto. Let's go and give our little test a try. So I've got my Android tablet because I'm going to need to put it in developer mode using the app. So let's start the app. I've already connected the Wi-Fi, by the way, to the Pluto. And we'll connect to the Pluto.
Pluto connected.
And it says Pluto connected. And I'll put it in developer mode. So I've hit the button. You'll notice the icon changed to a brighter color. The Pluto's now in developer mode. And so now let's grab the drone itself and see if our little program is working. And so the status light is this one over here, the one that's red at the moment. Now when I move it up, because the z-axis is increasing, you'll notice it goes green. As I go down, it turns red. Let's do this a few times because my hand's a little on the shaky side. Up is green, down is red. I'll tilt this so maybe you can see it a bit better. Up is green, and down is red. So it does appear to work. Now, one other thing that you might recall, though, is that in addition to controlling the status of the light, we're also writing to the monitor on the Cygnus IDE. So let's take a look at the Cygnus IDE and see how we do that. I'm just going to put this down for a sec. We'll go back to the computer. Now, the first thing we need to do is to link to the Pluto. So do a connect over here. This little icon will connect you. And now we'll go into the Pluto monitor. And as you can see, the Pluto monitor is displaying some stuff. I'm going to maximize the monitor right now so you can see it a bit better. So this gives me the Z velocity. And again, As I move the Pluto up, you'll notice we get positive numbers, and that's when it's green. And as I move down, we get negative numbers, and it's red. So that's the velocity thing. And let's move over here to Pluto graphs. Now the red graph is what we're driving. So as I move up, you can see it goes up. And as I come down, 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 and let's go even below the workbench here, it goes down, it goes up. So the graph is displaying the z-axis of the Pluto. And so that is essentially our hello world of Pluto applications. We're reading the status of the z-axis from the sensors in the Pluto, and we're using it to drive both the LEDs and the graph on the monitor on the Cygnus IDE. And so congratulations, you have run your first PlutoX program. Okay, so we've seen the hardware capabilities of the PlutoX. We've seen how we can program the PlutoX using the Cygnus IDE. There's really only one thing left that we need to take a look at, and that's to watch it fly. Now, as I said, I'm not going to fly it here in the workshop, but I'm going to take it to another end of the basement, and I'm going to give it a test. So let's go and do that and watch the PlutoX take off. So this brings us to the conclusion of our first PlutoX video. I am going to do more PlutoX videos because I really am excited about this platform, and I think it has a great deal of potential, and I wish the folks at Drona Aviation all the best and success for producing this product, both with their crowdfunding campaign and also beyond that. I think this would be an excellent product for the educational market. I think that parents who have kids that are interested in drones, and really all kids are interested in drones, rather than giving your son or daughter just a plain drone that they can fly around that's essentially a toy, this is a learning tool, and I think it has great potential over there. Now, there are a lot of aspects of the PlutoX that I haven't even covered yet right now. We haven't talked about the camera, we haven't talked about any of the basic X expansion boards or those little extra motors that allow you to make it into a hybrid drone. So this obviously merits at least one, if not more, videos on that, and I will be doing that. Now, if you want to see when those videos are released, the best way to do that is to subscribe to the channel. And if you want to do that, there's a little link just down there that you can click on for subscribing to the channel. There's also a little robot in the corner if you're watching this on YouTube, and you can click on him and he'll let you subscribe too, and that way you will know when I create new videos. I'd also like to remind you that there is an article on the PlutoX to complement this video. You'll find the link below for that on the dronebotworkshop.com website. And while you're on the website, please consider subscribing to my newsletter. This isn't a big sales pitch thing or anything. It's just a way of me keeping in touch with you, letting you know what I'm doing here in the workshop, and to give you surveys to find out what kind of material you would like me to create for you in terms of videos and articles. So please subscribe to the newsletter as well. Until then, take care of yourself, and I hope to see you again soon in the workshop. Goodbye for now.